Let's have a quick revision by doing some examples of chapter 10. Okay, chapter 10. I pick up some from revision exercise. Okay, you see that there are two x. Okay, one big x, surface area, this is 200 cm square, and the small one is 50 cm square. And then if take away this one, drop water drops 0.1 cm. Okay, now also take away this one. Okay, take away this one, drops. Okay, we see that we should be talking about volumes. Okay, volumes. And then you see that we have a formula, A1 over A2 equals to L1 over L2 all square. And then another volume, V1 over V2 is L1 over L2 cube. Okay, so you now know area. This one is 200 over 50, L1 over L2. So L1 over L2 is, this is 4, that is what 4, that is 2. Okay, so you know that the volume is 2 cubed, that is 8 times. Okay, so the volume should be 8 times. This one volume is 8 to 1 if I talk about volume. Okay, so the volume drops 0.1, or the water level drops 0.1, and then this one should drop 0.8 cm. Is it okay? So from 6 cm minus 0.8 minus 0.1 minus 5.1 cm. Okay, do you understand? Here I should highlight these two formulas. Okay, and then we look at another example about cone. This one is rolled up to form a cone. Okay, to form a cone, what I know is here this part is 22 pi. Is okay? And then where is the 16? This is the 16 cm. Okay, this is the 16 cm. In our first part, find the base radius of the cone, r. Okay, I know that 2 pi r equals to 22 pi. Therefore, I find r equals to 11 cm. Once I found out that this is 11 cm, I can find the height by Pythagoras theorem. Okay, the height h equals to root 16 square minus 11 square, which is root 135 cm. Okay, and then the volume is very simple, 1 over 3 pi r square h. Okay, you just put your r and h back, 11 and 145, and then you get the answer. Okay, so remember the formula of this one. Okay, and then this length is the perimeter. Okay, is the perimeter or the circumference. Okay, look at one more question. Okay, this one. Okay, find the total surface area. You see that there are 5 faces, but one is 6 and 10. You have 2 this one, and 2 this one. Okay, 6 and 13. So you use Pythagoras theorem to find out this, okay, the blue one, and use Pythagoras theorem to find out this, okay. So if you use Pythagoras theorem here, you find out that this is 12, and use Pythagoras theorem, find out that this is 160, okay. Then you are just finding the area of triangles, okay. Add them up, and then this one is solved. The height of the perimeter, okay, you see that this is 12, okay, this is 12, okay. And then you see that you can draw a triangle 12 if this is the height, and then you will see that this is 3. Sorry, this is 5. This is 5, okay? This is 5. Do you understand? Because here, this one, where is this 5? This 5 is here. This 5 is here. Okay, this 5 is here. Okay, okay, I better draw this. Look at this one. Okay, not 5. This is 6. Oh, sorry, this is, okay, that's why I have to draw it. This is the height, okay, this is the height, and I know that this is 12, okay, this is 12, this is 12, okay, this is 12, and then this is the height, I don't know, and then I change to green, okay, this part is 1/2 this part, okay, so this is 6/2, that is 3, okay. Using Pythagoras theorem, you can find out that the height is 135, and then once you find out the height, the volume is very simple, 1/3 base area, which is 6 times 10, okay, times the height, okay, would 135, and then you will get the answer, okay. And let's say the last example, which is a little bit difficult, which is an HKDSE question, okay. Find the volume of the empty space in the tank, okay. You see that here the height is 1.5, okay, and then the base is pi r squared, okay, so it is pi r squared times 1.5, which is 170 cm cube, okay, very simple. Find the volume of the pyramid, again very simple, 1/3, 9, 7, and 10, okay, which is 210 cm cube, okay. You see that it is somehow not difficult for HKDSE question, but the first few parts and the third part is a little bit difficult, okay. Let's see. John claims that if the pyramid is put into the tank, will the water overflow? Do you agree? Okay, some students think that they compare these two values, okay. So 210 is greater than 170 cm cube, so it must overflow. This concept is wrong because you did not put the whole pyramid into the water. What you put is just 5 cm, okay, 5 cm, okay, 5 cm. So what you put inside is this volume, not the whole one. The upper part is not put into the water, okay, not into the water. And you see that how to do it, okay. I look at it, here is 5 and 5, very good, and then 1 to 2, it is 5 to 10, but you have to take cube, okay? So it is 8 times, okay? So 1/8 210 is the upper part, okay, which is 26.23 at 25. And then so the frusum is 210 minus this value, which is 183, which is greater than the empty space, therefore overflow. Okay, you must emphasize, you must emphasize this value is greater than 170.